Hello everyone, welcome to IMS Gate Academy. I am Atul Negi, faculty at Mechanical Engineering at IMS Gate Academy. I hope you are doing your gate preparation well, and in this preparation we need to focus on previous year questions. Okay, like while doing preparation we need to focus on PYQ. The reason is from that PYQ you will be able to understand the level of questions that they will be asking from every chapter or subject. So in order to help you in that part, I'm solving theory of machine previous year problems, right? Hi Pragya. So in the last session we have solved GATE 2023 GATE PYQ question, and in this session GATE 2022 questions we are going to solve. So while solving the question also we'll be discussing the concept in detail, so that even if you're not familiar with the concept you will also understand the solution part. So when we are discussing the solution, please take a notebook with you and write down the solution, and as well as you should write the concept. Okay, so it will help you in your preparation. So only few months are left. At least we should cover last 20 years PYQ. Okay, for every subject, so that you will have a clarity regarding what kind of questions they've already asked. Right everyone? So we'll start the session with the first question from GATE 2022 from theory of machine subject. Okay, now this question is from the chapter governors, and the question that they have asked from the what governor. And if you see the previous year questions of theory of machine, specifically governor chapter, they have asked a very less problems, because already few years back only they have added this topic, and just now only they have asked what governor problem. Porter governor, Powell governor, Hartnell governor, they have not touched. So it's my advice to you is please cover those governors also, Powell, Porter and Hartnell, at least these three governors. Solve at least one problem from that, so that if the question is coming, and mostly they will be asking a formula based question from governor only, so you will be able to solve that problem also. Right, now just look at the problem that they have given. So there is a what governor they have shown. This is the ball we are having, and this is what the spindle axis. Right, now in the question they have given like friction is not there, we don't need to consider the friction, and it is spindle axis is rotating with angular velocity omega. Okay, now they're asking, the point here is the value of h is 400 mm at a certain omega. If omega is doubled, so they are asking if omega is doubled, what will be the value of h? H was 400 mm at certain omega value. Now if I double the omega, what will be the value of h? Now understand the point. The h is the height of governor. How we will determine the height of governor? The point of intersection of the upper arm. The point of intersection of upper arm and from the center of the ball in vertical direction, that will be called as height of governor. Very important point, right? See, from the center of the ball, to this point of intersection, it is known as h, height of governor. This is what we call as height of governor, right? So this is a very important point here. Okay, from the center of the ball to the point of intersection of the this upper arms at the spindle axis, from that point to center of the ball in vertical direction is your height of governor. What is radius of rotation? From the center of the ball to the axis of the governor or the spindle axis, that distance is what? Radius of governor. So height of governor and radius of governor should be clear to you. Now as a one more additional point that you should remember, so what I have told you, this is a simple case of governor. There can be a different case, open arm, cross arm, right? What is the open arm case? See, open arm case, how it will be there? This is the upper arms, not connected with the spindle axis like this. Okay, this is your ball and this is like this, and here there is a sleeve. So this is what known as open arm type. So where you will take the point of intersection of the arm? Here they are fixed at this point, your upper arms. So in that case, we need to extend this upper arms, and wherever they are intersecting, that point I will take, and from the center of the ball in vertical direction, it becomes our height of governor. So it is an example of open arm type governor. Now there is one more case, cross arm type governor. That also you should remember, because such basic variations at least you need to remember. Okay. Now what is cross arm type? So this is your spindle axis, right? Your upper arms are crossed like this. This is the fly balls. Again, this is the lower arms connected with the sleeve. Now, at this point, it is intersecting. Okay, at this point, it is intersecting, and from the center of the ball, this is your height of governor. So, cross arm also you should understand, open arm also you should understand, and this is a simple case of governor, right? What is height of governor and radius of governors? Both the parameter should be clear to you. Okay. Now, coming back to the problem, what they have asked. In the case of watt governors, everyone should understand the point here is your height of governor is equals to G by omega square. This is the formula that everyone should understand for watt governor. This question is from direct application of the formula, right? So for watt governor it is H equals to G by omega square. Now, so as they have told in the problem, when omega was the height, okay, when omega was the height, omega was the radius of rotation, height was 400 mm. Now, question is, if omega is twice, so then what would be the value of H? That is the question. I hope the point is clear, everyone. So if omega is doubled, that is radius of basically the rotational speed. The rotational speed is what doubled, then what will happen to the value of H? So as I told you, from the formula we can take a relation. What is the relation? Relation will be simple. H will be inversely proportional to omega square. This is the relation for watt governor. Clear? So this is the relation, H is inversely proportional to omega square. So now further how I can modify this relation? See, I can use it like this. H1 by H2 equals to omega 2 square by omega 1 square. This will be my formula. Simply I will be putting all those values here, and I can easily calculate H2 also. So this H1 value is 400, H2 value that we need to find out. Omega 2 was twice of omega. Initial omega was simply omega square. From that you can easily get the answer of H2 as well. So I hope you will be able to solve it now. So direct application of the formula. So in the case of governors, at least you need to remember the formula of watt governor, Porter governor, Proel governor and Hartnell governor, right? All those governors formulas you need to remember directly, and directly putting the values you will get the answer, right? So I hope you have solved already. So please tell me what will be the answer. What will be the answer here? Tell me fast. So 2 square becomes 4 and 4, and this is a 400. So directly what answer you will be getting? 100 mm is your answer. 100 mm is the answer here. So for watt governor you need to remember this relation. Okay, H is inversely proportional to omega square. And one more relation. In terms of RPM, it will be H equals to 895 by N square. That is another relation where N is an RPM, revolutions per minute. Here the angular speed, radian per second, it was there. right? Omega, radian per second, angular speed. Here RPM it is there. So this relation and this relation you need to remember. So if I see the option B will be correct here. Okay, option B will be correct, 100 mm. So direct formula based question it was there. Now coming to the next problem, and this was very interesting problem. Most of the student usually tell me, sir, this is the tough question. No, it is not tough. If you understand the basic concepts of engineering mechanics, how to calculate mass moment of inertia of any body, right? If that is clear to you, then this problem will be very easy for you also. Okay, as we have already solved many problems in the classes also. How to calculate natural frequency of vibration, and steps are what? Simply disturb the system from its static condition, and based on the disturbance, what will be the effects? Forces will be there, moments will be there, torque will be there. Accordingly, you should write the equation of motion, and from that equation of motion you can easily calculate omega n as well. Okay, but the main challenge that everyone has faced here is to calculate the mass moment of inertia value about point A. The most common challenge everyone has faced to calculate the mass moment of inertia value about point A. So that's why I'm telling, in theory of machine, if your concepts of engineering mechanics are good, then you will feel confident, because you will not stuck in the problem because of mechanics concept. If mechanics concepts are clear to you, then you will enjoy theory of machine subject. See, the reason is some of the subjects we are not able to enjoy because for that subject some fundamentals are required, and if that fundamentals are not cleared, so then definitely you will not be able to learn that subject, and obviously you will not enjoy the subject also. So please always remember, whatever the fundamental subjects are there, like engineering mechanics, thermodynamics, fluid mechanics, all those subjects you should prepare well, so that application related subjects you can easily enjoy and learn also, right? Now coming back to the problem, they're asking they're asking what? This beta value. Now what is T here? They have mentioned T is your time period of oscillation, and time period of oscillation they have mentioned as beta pi root over R by G. This is the format in which time period they have given. Now the question is, they are asking the value of beta. So obviously what will be the our step? First, calculate the natural frequency. Why? Because with the help of natural frequency, we will be able to calculate the time period, and whatever time period you will be getting, you will equate with this thing. You just compare your time period of oscillation with this relation, and by comparing you will get the answer of beta as well. By comparing your time period of oscillation value with this, you can easily get the answer of beta as well. So first we will be calculating the natural frequency of vibration about point A, and from that time period of oscillation we will calculate. Now for your information, how to calculate all those things? See, first of all you should understand frequency of vibration is what? Omega n by 2 pi. Time period of oscillation is inverse of this frequency of vibration. So what will happen? Simply 2 pi by omega n. So first calculate the omega n value, then directly put in this formula of time period 2 pi by omega n. Okay, done. So first we are going to solve for solving natural frequency. Now the step number 1 is to disturb the system from its static equilibrium condition. Okay, now this is the axis we are having. Okay, this is the axis we are having. Now what I will do, I will disturb the system. So when I will disturb the system, its axis will turn like this. So I have provided, now here very important point, I provided the disturbance in this anti-clockwise sense. This is my theta. Angular disturbance I provided to the ring. Now because of this angular disturbance, what will happen? That CG point where the weight is acting, the point where the weight is acting, it has been shifted. It has been shifted. Shifted to which point? Shifted to this point. Okay, shifted to this point. And from there the weight will be acting. from there the weight will be acting. This is the weight. Initially CG was there because you have provided this kind of disturbance. You have rotated like this. This is your disturbance. That's why the weight has been shifted towards right. If I provide clockwise, then the weight will shift towards left. Simple thing. Very easy. Now, see. Because this disturbance is there, opposite to that, what will happen? Inertia torque will be coming. I theta double dot. And that I value will be about point A, where the rotation is happening. The point where rotation is happening, A. Next thing, what is the next thing? The weight will be having some moment about point A. For that, this will be the distance. So again, in what direction moment will be there? Clockwise. Your weight, that is mg, multiplied by this distance is small r theta. This is the torque that this weight W, which is mg, will create about point A. Mg r theta will be the torque or the moment developed by this mg about point A. All values we have written. Just now we will write the equation of motion. We will be writing equation of motion. Equation of motion will be I theta double dot plus mg small r theta equals to 0. Moment of inertia about point A. Now that part we have done. Till this point everyone was comfortable. Now the real challenge will come to calculate the mass moment of inertia about point A. For that, as I told you, the basic parts. You should be knowing the basics. So now how I will do it? See. In order to calculate the mass moment of inertia about point A, first of all you will write the mass moment of inertia about CG. Plus then mass into distance square. Which distance square? Distance between your CG to your point of rotation. From CG to your point of rotation. What is the distance? Small r. That distance square we need to do. CG mass moment of inertia is m. Okay, smaller radius to larger radius, or we can say furthering, inner radius to outer radius. Inner radius is r square, small r square, capital R square is the outer radius, divided by 2, right, plus mr square. Now, in the question, if you see, they have given one relation. What was the relation? R square, small r square is equals to capital R square by 2. Okay, the relation given is small r square is capital R square by 2. So that value directly I will be using. Okay. So if I use that value here, so m capital R square by 2 plus capital R square, it is like this, and the whole divided by 2 plus capital R square by 2. Now, so it will be 3mr square by 4 plus mr square by 2. Now again we will take the LCM. So finally, what will be getting? 5mr square by 4. 5mr square by 4. So this is the value of mass moment of inertia of this ring shaped disc about point A. And here only the maximum people has done the mistake. Okay. So I hope now the idea is clear how to calculate the mass moment of inertia about point A. So simple parallel access theorem we need to apply. So from the parallel access theorem we can say, let's suppose you want to calculate mass moment of inertia of a body about any other point apart from its CG. So first step is write down CG mass moment of inertia value plus mass multiplied by distance square. Which distance square? Distance from the CG to the point of rotation. That distance square you need to do. And finally you will get the mass moment of inertia value as well. Now using this value I will put here and I will solve the question. Okay. Now the question becomes very easy. See. So our equation was mg small r theta equals to 0, 5 by 4 mr square theta double dot mg, okay, r by root 2 theta equals to 0. Because we have the relation, So R will be capital R by root 2. Okay, now theta double dot mg R by root 2 divided by 5 by 4 mr square equals to 0. Now omega n value will be under root of this thing, m will get cancelled out. Okay, this r will be there as it is, so 4 it will be there, 4 will go into the numerator side, thus 4 is there, it will go to the numerator side. G will be as it is, 4g it will be there here in the denominator, 5 into root 2 into r. That is what the omega n we have solved. Okay, that omega n value we have solved. So radian per second. Now next thing is what? The time period of oscillation. Okay, next thing is your time period of oscillation. Time period of oscillation will be simply two pi by omega n. 2 pi divided by omega n. Now omega n value under root 4g by 5 root 2 into r. So what I will do, omega n, so numerator will come into the denominator side, so root 4 into g. Okay, so I will make one square root only, no issue. Here 4g will come, here 5 into root 2 into r will be coming. Now this is the time period we have solved. Now what was given in the question? In the question they have given like this. So we will put it equal to this relation that we have solved and compare the value of beta that they are asking. Okay, so we'll be writing the value of the time period of oscillation that they have given. In that format only we'll be writing. Okay, they have given like this, beta pi root over r by g. That is what they have given. So let me check again. Beta into pi root over g, correct. Now so what I will do, I will separate out this constant values, this values, pi as it is I will put, in root over r by g I will keep separate, and whatever the value here I will be having, that will be equals to beta. That will be equals to beta. Clear? So what I have done here, please understand the point. What I have done, I have separate out this pi value, root over rg value I have separated out. Whatever numerical value will be there, I will be solving there, and that value will be equals to beta. And finally, that beta value you can easily solve from this. So I want everyone to solve it. Do it fast. Everyone please do it. So what will be your answer? Do it fast. So just comparing it, we will be getting the answer of beta as well. Okay. So the question was easy. The main problem that everyone has faced regarding this. So calculation of the mass moment of inertia are like very important in theory of machine subject. So again I am telling you, please again make sure that engineering mechanics basics are clear to everyone. If it is clear, then it will be very easy for you to understand the engineering theory of machine subject also. Machine design, strength of material, all subject becomes easy for you if the mechanics concepts are good. Okay. So just solve it, and I'm waiting for all the solution. So do it fast. Okay, so final answer is coming around 2.66. Okay, 2.66 it will be coming. So you can do the calculation later on also, but this is what we are having as an answer here. Clear? 2.66. Yeah. Okay, Deepak. Okay. So the point is, theory of machine vibration topic. If you see, mostly question they have asked from the vibration topic. And the vibration part, see, totally dependent upon the engineering mechanics concept. Okay. So please try to clear your concepts from the engineering mechanics. Then it will be very easy for you to solve any problem of the vibration. Okay. And remember this formula, mr square, capital R square by 2. So I will write separately also for you. Okay. So if there is a disk we are having, right? This is a disk, let's suppose. Okay. So this is the ring we are having. Okay. Ring shaped kind of thing we are having. So the inner radius is R1, outer radius is R2, right? So the mass moment of inertia about the CG will be m R1, okay, m R1 square plus R2 square. Okay, this is the formula we are having, m R1 square plus m R2 square. Now in some cases they will be saying, okay, take R1 equivalent to R2. So what you will be writing then? mr square will be your resulting answer of the mass moment of inertia, because this R1 and R2 values are equivalent, so it becomes 2r square. That 2 will get cancelled out with the denominator 2. So final answer will be mr square, right? Okay, now moving to the next problem. Now this problem is from the simple mechanism chapter, the chapter number 1 in theory of machine we are having, right? And this question is related to Grashoff's law. This question is related with the Grashoff's law. Now in this problem, most of the student has done the mistake, and the mistake is what? They have understood what is Grashoff's law. They know all the cases, but what they have missed is the basic one point, and that point is what? In what cases this Grashoff's law will be applicable, under what cases it will be applicable. What is the condition of Grashoff's law? So what we tell, for the 4-bar mechanism, it will be applicable, but in this problem you will understand there is a member which is sliding, this B part, it is sliding in this link CDE. So that is a sliding pair, and Grashoff's law is applicable for on 4-bar mechanism where all the connections or the joints, all the pairs are simply the hinge joint or the turning pairs we are having. Here we are having sliding pair. So how it is possible to apply the Grashoff's law in this case? Is it possible? No, it is not possible for us to use the Grashoff's law in this particular case. So then what to do? So the thing is there any possibility that we can convert this sliding pair into turning pair? Is it possible? That we need to understand here. And that's why 90% student has done the mistake in this problem. Because just by seeing the Grashoff's law, everyone has this idea, okay sir, smallest plus longest less than P plus Q, this kind of relation. Everyone knows. But the point is, they miss in this particular problem is, it is applicable to 4-bar mechanism, and 4-bar is that mechanism in which all pairs are turning pair. Clear? Now, how to convert this particular case into our turning pair case? See. So remember this point first of all, Grashoff's law. Four-bar mechanism. And 4-bar mechanism basically means all are turning pair. All are turning pair. This point is very important. All are turning pair. Now, we'll discuss the concept here, like how to convert that turning pair into sliding pair or sliding pair into turning pair. Okay, see. So let's suppose we are having a 4-bar mechanism here. Okay, so this is a 4-bar mechanism we are having, and all are turning pairs. Okay, all are turning pairs. Now, what I will do here in this particular case, I will do one thing. I will shift this pair to the infinity. What I will do, I will shift this pair to the infinity. Then what will happen? Actually, this point is rotating with respect to this point. Correct? Can I say? This point is rotating with respect to this point. Yes or no? Basic point. This point is under rotation with this point. Now, if that point is at infinity, then what will happen? Okay, think about it. What is going to happen if that point is at infinity? So, take this point at infinity. What will happen? Simply the concept that you need to remember here is, if the radius of rotation is infinite, you will not have the curved motion, you will have a straight line motion. Okay, see, simple fact I will tell you here also. So that is the center of rotation, and this is what radius of rotation. It has turned by some angle, let's suppose theta. This is radius r. This is what the distance it has traveled for this rotation. So S equals to r into theta, right? If my radius of rotation is infinite, then what is the value of theta? 0 degree. It means that is, now it will not be a curved path, it will be a straight path. If theta is 0, then this path will not be curved, it will be a straight line. So I can say, if that point has been shifted to infinity, that point will not be rotating, it will be just sliding only. So what conversion you will see here? What will be the conversion part? See, this is hinge as it is. Okay, this is also turning pair. Done. Now what is going to happen here? It is going to slide. So when it is going to slide, so I can show and I can represent it with like this. Now this kind of thing you will see. So this single slider crank mechanism is the limiting point of this 4-bar mechanism, when one of the turning pair has been shifted to infinite. I can say like that. So that single slider crank mechanism, this is a single slider crank mechanism, which is a basically limitation of this 4-bar mechanism, when one of the turning pair has been shifted to infinite. So the concept that we have understood from this case is, whenever you want to convert any turning pair into sliding pair, just shift that turning pair to the infinite. So what is going to happen? Now this point, which is rotating initially with respect to this point, so that was the radius of rotation. Now the radius of rotation becomes infinite because now this turning pair is at infinite. So once the radius of rotation becomes infinite, there will not be any rotation kind of thing. You will see a straight line motion. Right? That is the concept you need to understand. I hope this point is clear to everyone. Right? So that concept I will be using in this particular problem. Okay, everyone? See, Now see the problem here. Right, so now what I will do, so this B is what sliding on this link CDEF. This is a complete T link. It is already mentioned in the problem. CDE. Okay. It is a complete one link. They have already mentioned. Now it is sliding. So I need to convert it into turning pair. So what I will do, simple thing. I will shift it to infinity. Okay. So let's suppose we have shifted at infinity point. Now once this point has been shifted to infinity, at this point you should apply your common sense. When this B is at infinity, obviously D also be in infinity, because C, D, E, F, this is a complete link. It also has to be at infinity. Because the slider is what sliding in which link? C, D, E, F. If that slider has been shifted to infinity, so this T member or T link will also get shifted to infinity. Right. Now I can apply the Grashow's law. Now apply the Grashow's law. Now what is the Grashow's law? The smallest plus longest. Smallest and longest. What is the smallest link here? Tell me. What is the smallest link? This 3 is the smallest link. So I will write here smallest link plus longest link should be less than or equals to P plus Q. P and Q are the another link dimensions. Smallest is 3. Longest will be what? 3 plus this. Let's suppose this distance is L infinite. So 3 plus L infinite. Okay. So smallest is 3, longest is 3 plus L infinite. Done. Now what about P and Q? P will be one of the dimension for the P will be 5 and another one will be 1.5 plus infinity. So 5 plus 1.5 plus L infinity. Now obviously 6. 1.5 plus 5 is 6.5. So it will be obviously greater than this. L infinite will get cancelled out. So you can easily say 6 is greater than 6.5. Okay. 6 is less than 6.5. That point. Correct? Yes, correct. 6.5 is your correct answer. Okay. So 5 plus 1.5 becomes 6.5 and this value will be greater than 6. Now Grashow's law is valid here. Grashow's law is what? Valid. Now if it is valid, which particular case will be there? Now to identify which particular case it will be, you need to understand one thing. What is that thing? You need to understand which particular link is fixed here. Now see the mechanism and tell me which particular link is fixed. The link having 3 dimension, which is smallest. Smallest link is fixed. The third GF member, which is the smallest link here, which is what? Fixed. So when smallest is fixed, so what is going to happen? Double crank mechanism you will get. Double crank mechanism you will be getting. Correct? Yes. GF is the smallest link. So which is smallest? Smallest fixed double crank mechanism. Correct. Now double crank mechanism basically means this AG member and this CDF member is what? Rotating. Now here you have to visualize the mechanism. If CDEF, that T link, this T link is what? Under rotation, obviously this AC link will also rotate with that. When this T link CDEF is under rotation, right? So then definitely when this T link is under rotation, what is going to happen? this AC or this AB link, basically AB link will also get rotated with that CDEF T link. So both will rotate, right? And obviously double crank is there, so AG, the input and output will be what, rotating. Yes, AG will be the crank. CDF will also under rotation, so it will also considered as crank, double crank mechanism. Once CDF, this T link is under rotation, definitely AB has to rotate along with that. That's why all members except the fixed member are what, under rotation. That is what our analysis here. Okay, that is what our analysis. So accordingly, we can see option A, Grashof chain with link AG, AB, AG, AB and CDEF T link completely rotable about the ground link FG. So answer will be for option A. Answer will be option A. Correct? So in this particular problem, the main concept is this one. Once this point has been shifted to infinite, so when this point has been shifted to infinite, it means radius of rotation becomes infinite. Radius of rotation infinite becomes, means this point will be under straight line motion. Simple thing you should remember, r infinite, theta will be 0. Theta 0 means straight line motion, sliding. Right? Now, coming to the next problem, gate train. See, in every year gate train problem they will be asking. And this epicyclic gate train are the favorite questions of the gate examiner. Every year, maximum questions from the gates are from epicyclic gate train only. And I will tell you the concept here, the relative velocity method with which we will be solving this question. This questions will be a matter of second for you if you understand the velocity, relative velocity method here. There is a conventional method to solve using a table, and that method will definitely take more time compared to relative velocity method. Right? So we'll be first solving this problem with the relative velocity method, and that method you should apply for all problems of epicyclic. You can get answer in seconds, right? Now, first of all, I will write down the details that they have given. Okay, detail they have given is what, gear 1, gear 3 and arm OP are pivoted to the ground at O. Okay, gear 2 is carried on the arm OP via the pivot joint at P. Okay, it is given. Now, gear 1 is fixed. This is very important. If gear 1 is fixed, it means omega 1 will be what, 0. That is the point. So, given parameters, first of all, I will be writing. Okay, and gear 3 rotates. Okay, they have given the RPM, so I will write N3. N3 is given as 900 RPM. Counterclockwise, CCW. So now it's my choice to take it as positive or negative. It's my choice. Okay, clear? It's my choice whether I have to take positive or negative. Accordingly, I will be getting the answer. So we don't need to worry about that. In the question, magnitude of the angular velocity of arm OP they are asking. Okay, and number of teeth they have mentioned along with the gears in the diagram itself. Now see. So first of all, what I will write the relative velocity equations. Relative velocity equations I will be writing. First, speed of gear 1 in terms of RPM I will write with respect to arm, and speed of 2 with respect to arm. So why I have taken like this? Because 1 and 2 are direct meshing. There is a direct meshing between gear 1 and 2, and taking arm as a reference, I can write down the relative velocity. 1 and 2 will have external meshing, so minus sign will come T2 by T1. So that is relation number 1. Another relation, 2 and 3 are under meshing. When 2 and 3 are under meshing, but that meshing will be internal meshing. So same sense of rotation will be there. So N2 with respect to arm, 3 with respect to arm, T3 by T2, and here the positive sign will come. The reason you should understand why negative and why positive there. Negative because the sense of rotation is opposite between 1 and 2. But gear 2 and 3, sense of rotation will be what? Same. That's why the positive sign comes. Now see. using equation 1 and 2, from 1 and 2, if I use 1 and 2, so basically what I'm doing, I'm multiplying both the equations. So this 2 with respect to arm will get cancelled out. Minus T2 by T1 multiplied by T3 by T2. So 1 with respect to arm can be written as N1 minus N arm. Minus N arm. So 2 will get cancelled out. So T3 by T1. This is the relation. Now T1 value, number of teeth they have not given for 1. Okay. T3 they have given, yes, 80 teeth they have given. Arm we need to find out. Radius, angular velocity or the RPM of gear 1 is what? 0, because it is fixed. 3 they have given. Okay. The only unknown we are having is what? N arm, that we need to find out. Apart from that, T1 value. Now here the major problem will come. How to solve the T1 value? Again, for that you need to look at the epicyclic gate train, okay, and think about the geometry that they have given in this epicyclic gate train. Okay. Now just observe the epicyclic gate train. Is it possible to write any relation based on the geometry? See, can I say radius of 1 plus diameter of gate 2 will be equal to the radius of gate 3? Radius of gate 3 is equals to radius of gate 1 plus diameter of gate 2. Right? So according to the given epicyclic gate train, what I can write? Radius of gate 3 equals to radius of gate 1 plus twice the radius of gate 2. That is what diameter. Now, you should understand a very important point here. How to write the relation of radius with the module. Module is given as d by t. So instead of writing diameter, I can write twice of radius. So radius can be written as m into t divided by 2. So this relation of r with respect to module mt by 2, you should remember directly. R equals to mt by 2, you need to remember it. Okay. So see how I will write here. Right. So R3 value, what is the R3 value? MT3, MT1 by 2 and twice of MT2 by 2. Now module will be same for all the gears. Reason why it will be same? Because 1 under meshing with 2, 2 is meshing with 3. All gears are meshing with respect to each other. When they are meshing with each other, so definitely module value has to be what? Same. Okay, so module value is same, so it will get cancelled out. I know the value of T3, I know the value of T2. T1 I can easily find out. So please tell me what is the value of T1 here? What will be the value of T1 here? Do the calculation and tell me the answer first. What will be the answer of T1? T3 is 80, T3 value is 80, T2 value is 20. What will be the value of T1? Okay. So I will write in the next page here. So that T3 by, so this 2 will also get cancelled out. This 2, denominator 2, it will get cancelled out. M also get cancelled out. So what will be there? Only T3 equals to T1 plus twice of T2. It is 80. T1 I need to find out. 2 into 20. So T1 value finally you have as 40. That value I will utilize here in this relation. In this relation I will utilize this value. So this was the relation that I have to use. Let's suppose equation 3. So from 3, N1 minus N arm divided by N3 minus N arm T3 by T1. So N1 value 0, arm we need to find out. N3 value was 900 counterclockwise. Let's suppose I am taking negative for counterclockwise. T3 value was 80 and T1 value was 40. Right? We have calculated T1 value 40, T3 already given as 80 teeth, and N3 value was 900 RPM. So N3 value also we have written, but we have kept negative sign. Negative sign was because of the counterclockwise direction. If you want to keep it positive, you can keep, no issue. Now do the calculation and tell me the answer here. Of N arm. What is the answer of RPM here? 40 is the number of teeth, correct? $600, but with sign it will be minus 600. And the reason, the point that you need to understand, means counterclockwise. And here if you see in the question they have asked magnitude. They have asked only the magnitude. So we will not keep the positive or negative. We will write answer. What is the number? Magnitude only we will be writing, not plus minus. You can get positive also if you take counterclockwise positive. In that case you will get the answer as positive. But remember, they have mentioned in the question only, take the magnitude only. Use magnitude. So answer is 600. Finally, our answer of RPM of arm is 600 in RPM. That is what we are having as answer. Clear? Done? Okay, coming to the next problem. Yes, this was a very interesting problem, and here little mathematics, that is what required here. Okay, some mathematics part is what required here. Okay, see, consider a forced single degree of freedom system governed by the equation that they have given. This is our damping factor omega, and everyone knows. Okay, now what they have given, undamped natural frequency of the system respectively, while omega is the forcing frequency. Okay, omega is the forcing frequency, omega is the natural frequency for undamped system. Okay, for damped system it will be omega d. Now amplitude of the forced state response of the system is given by this relation. Okay, peak amplitude of the response occurs at a frequency omega p. Omega p peak frequency, omega n undamped natural frequency, omega d damped frequency. Okay, this thing you should clear. Now omega d denotes the damped natural frequency. Okay, which of the following options will be correct? The point that we need to note here is the peak amplitude of the response will be at omega p. This is the point. This point everyone should remember. Okay, because this is the main thing that we need to understand. Done? Now we'll write the equation first of all, this relation that they have given. 1 minus r square, 1 minus r square, the whole square plus 2 psi into r whole square. Okay, that is what given. In under root it is there. So they have given like this. Okay, so the amplitude they have mentioned of the steady state system is like this. This is what they have given, right? Now, so omega p, omega n, omega d. Okay, one by one I will mention the point here. Okay, first of all you need to be clear regarding this. What is omega? Omega is forcing frequency. Frequency at peak amplitude. because that is what they have given. Okay, the peak amplitude of the system occurs at a frequency omega p. So frequency at peak amplitude was omega p. Omega n, undamped natural frequency. Then finally we are having omega d, damped natural frequency. Right, so all the frequencies should be clear to you, right? Damped natural frequency they have given. Okay, now all the frequencies are clear to everyone? Tell me, is it clear? Because if these points are clear, then we can easily relate, because we need to relate what? Omega p, omega d and omega n. How they will be related, which value will be more, okay? Compared to omega p, omega n, omega d, which value has more magnitude? That is what we need to find out. And accordingly, relations they have given. Okay. Now, amplitude of vibration they have given. Okay, the amplitude of the force steady state response of the system is given by this relation. Now, if I am able to differentiate that relation and equate with the 0, I will get the answer at what frequency I will get the maximum value. Okay, so that relation I will be getting, and from that relation I can compare the frequencies. From that relation I can easily compare the frequencies also, right? So the main thing is, this is the relation they have given. So what I will do, okay, so the first step that I need to take here is, I will differentiate with respect to frequency. R is the frequency ratio, right? So it is like this they have given. Now see, minus 1 by 2 it is they have given, so it is like this, 1 upon, it is in the denominator. Okay, now as it is in denominator, or power directly we can write as it is given in the question also, minus 1 by 2 we should write. It will be very easy to write, so no need to put the complete square root sign here. The power minus 1 by 2. Okay, we will differentiate it and equate with 0, and what I will do, I will find out the value of R. I will find what value of R. So R is what? Nothing but omega by omega n. Omega will become omega p here, because for that value of R, this whole amplitude becomes maximum, and when amplitude is maximum, frequency is what? Omega p. So omega p we need to put here. You will be getting some relation. So omega p, omega n you can easily compare. And one more thing, like omega d, damped frequency of vibration, is omega n. This is the relation that everyone knows. So this relation everyone knows. Okay, that is fine. But we need to compare omega p and omega n. Omega d and omega n we can compare it, but the point is to compare omega p and omega n. Can you tell me what will be the value of R? If you differentiate this thing with respect to R, what differentiate with respect to R and equate with 0 also. So for what value of R it will be maximum? So calculate this value of R and tell me the answer. Tell me the value of answer also. With respect to R and equate with 0. Okay. Do the differentiation, that is basic differentiation that you need to do here, and tell me the value of R here. Everyone should try. See, sometimes mathematics will create a problem for us, right? So it should not be like, okay, you know the concept, but because of mathematics you are not able to solve it. Okay, so power minus 1 by 2, if I differentiate, it becomes minus 3 by 2. Okay, so minus 1 by 2 will come here, power becomes minus 3 by 2 and in denominator it will be 3 by 2. So directly I am skipping some of the steps here. Power becomes 3 by 2. Obviously minus 3 by 2 but in the numerator side. Then we will differentiate whatever is there in the bracket. Now differentiation of this one, 2 into 1 minus r square into minus 2r, it will be there because minus r square differentiation minus 2r. We'll keep the different bracket here. Okay. Then plus 2 into this is the square, no? So what I will do, 2 psi is a constant, so we'll keep it constant separately. R square differentiation is 2r. Okay, and this thing should be completely equals to 0. Now this is what 3 by 2. So this is what a positive quantity. It cannot be 0. Minus 1 by 2 again it cannot be 0. Only this numerator can be 0. So what I will do, directly I will equate the numerator with 0. Right? There is no need to take this thing because it is already a positive quantity. Right? So what I will do here, I will take the numerator as equals to 0. So 2 into 1 minus r square into minus 2r plus 2 psi whole square into 2r equals to 0. Now solving it further, so 2 into 1 minus r square into 2r equals to 2 psi whole square multiplied by 2r. Now this 2r value will get cancelled out with this one, okay, and this 1 minus r square, so this becomes 4 but this 2 is there, so it becomes 2 psi square. So r square actually equals to 1 minus 2 psi square. So r value will be under root 1 minus 2 psi square. Now as I told you, this is that r value for which the amplitude will become maximum. When amplitude becomes maximum, it will be for at what frequency? Omega p. So that r value we have solved, that r value omega p by omega n. So omega p is what? Omega n times under root 1 minus 2 psi square. Done. So this is the relation of omega p. Now compare it with omega d, damped vibration, omega n multiplied by under root 1 minus psi square. Okay, now you can easily compare. Okay, now you can easily compare. So which value will be what more? Obviously omega n is the biggest value here. Compared to that, omega d is less or omega n? Omega d or omega p? Which value is what less? Okay, comparing to omega n, see, like if I compare with omega n, omega p and omega d both are less, but if I compare both this omega p and omega d, comparing omega p and omega d, which value is what less here? Just compare the omega p and omega d, which value is less? See, we have both the relations of omega p as well as omega d. Compare it and tell me which value will be less. Omega n, definitely it will be large value compared to all three. Okay, compared to all three values, omega n is the large. But if I have to compare omega p and omega d, which value will be large? Tell me, final answer. If you see the relation omega p under root 1 minus 2 psi square, it will be a less value as compared to omega d because 1 minus psi square it is there. So compared to omega n, you will have omega d here, and then compared to that omega p you will be having. So finally answer will be what? this one, the relation between omega n, omega d and omega p. See the relation, under root 1 minus psi square, under root 1 minus 2 psi square. Yes, correct. Omega p is the less value. It is the less value. Because 1 minus 2 psi square. So this value is what? Less as compared to this one. So overall, I can say omega p is less compared to omega t. So if I see the options here, which option will be correct? Tell me, which option will be correct here? Option A. Omega p is less compared to omega d further less as compared to omega n. So omega n is the large quantity, then omega d, then omega p. Answer will be option A. Okay. So answer will be option A here. Done, everyone? So answer will be option A. So this relation everyone should remember directly. This omega d. This is very important. Directly you should remember it. Otherwise, if you don't know this relation, you will not be able to compare it. Right? So this complete, see, it looks to be difficult to differentiate, but it is not. Simply take minus 1 by 2 differentiation. If you do, minus 1 by 2 will come outside. Minus 1 by 2 minus 1, minus 3 by 2. But minus 3 by 2 in numerator. If you take it into denominator, it becomes 3 by 2. This is a completely positive quantity. It cannot be negative. So that's why I have taken only numerator and equate with 0. From there I got this answer of frequency ratio. Right? Done. Moving to the next problem. Right? Again, very important concept of angular velocity ratio theorem. Every year from simple mechanism of velocity analysis, in mechanism there is a topic here, velocity analysis. Every year they are asking one kind of problem from this to calculate the velocity of any link. All this kind of problem can be solved with the help of angular velocity ratio theorem. With the help of angular velocity ratio theorem, you can solve this kind of problem very easily. Within 1 minute you will be able to solve it. But the point is, for that you need to know how to locate I center. If you know how to locate I center, then this question becomes a matter of second for you. Okay. So as given the problem, omega 4 centimeter they are saying, and for that they are asking the velocity. Omega 2 they have given as 5 radian per second, and remaining dimension is mentioned in the diagram itself. Okay. So the main thing is omega 4 they are asking. Using angular velocity ratio theorem, right? See, omega 4 by omega 2. Why I have taken 2? Because 2 value they have given directly. So omega 4 by omega 2 can be written as, see the method how I am writing. Distance from the common I center 2, 4. Take the distance of common I center 2, 4. Okay. To that I center, where to that I center, that is for the link 2 with respect to fixed. Fixed is 1. So I12. Take the distance in the denominator also. In denominator also, take the distance of common I center from that I center which is there in the numerator, that is 4, with respect to fixed, that is I14 or 41 or 21, same thing. 12 or 21 are same thing. 41, 14 both are same thing. So you need to know how I am writing this relation. This is very, very important. How to write this relation, this thing should be clear to everyone. Right. Now the point is, sir, where is I24, I12 and 14? That is what we need to figure out first of all. First of all, see, this is member 1, this is 2, this is 3, this is 4, and okay, all 4 members I have mentioned, all links. This is I12, 2, 3, 3, 4, this is I14. Now the point here is, sir, how to locate 2, 4? See, there is a small trick that you need to understand. Okay. this is 1, 2, 3 and 4 link. Right. What is the trick here? Please understand. I want to find out 2, 4. So see, in order to go from 2 to 4, what is the common, what is the distance that you will take? 2 to 1 and 1 to 4. Another way is 2 to 3 and 3 to 4. There are two ways possible. 2, 1, 1, 4, 2, 3 and 3, 4. These are two ways. So the first way is I12, then I14. 1, 2, 1, 4, then you can take I23 and 3, 4. Now you will say, sir, what is the logic behind this trick? Kennedy's theorem. Yes, absolutely, Kennedy's theorem. So if I consider the link 1, 2 and 4, try to understand. If I consider the link 1, 2 and 4, the I centers, because 1, 2, 4 are having relative velocity with respect to each other, relative motion basically. 1, 2, 4 are the three links and they are having the relative motion with respect to each other. So definitely their I center will be in a straight line. So what are the I centers here for I124? See, I12, I14 and I24. These are the three I centers you will be having. Now take another members, like you can take 2, 3 and 4. So what are the I centers associated with these links 2, 3, 4? I23, I34 and I24 here. Correct. 1, 2, 4 are the three links having a relative motion with respect to each other. Three I centers. 2, 3, 4, three members, three links having relative motion with respect to each other. So 2, 3, 3, 4 and 2, 4. These are the I center. So all three I centers should be in a straight line. Now, what is the common thing between these two lines? You have to draw one line. Okay. So you need to draw a one line using this I centers. Another line you have to draw using this I centers. In both the lines, I24 is a common point. So whenever both the lines get intersect, that point will be I24. So the whole concept behind this trick is basically Kennedy's theorem. Whenever three bodies under relative motion with respect to each other, their I center will be in a straight line. So 1, 2, 1, 4, 3, 2, 4, one straight line. 2, 3, 3, 4, 2, 4, one straight line. Wherever both the lines intersect, common point is 2, 4. Now see. So the line between 1, 2 and 1, 4. I know 1, 2 and 1, 4. Here it is. Okay. So 1, 2, 1, 4, 2 points are there. 1, 2, 1, 4, 2 points are there. Now, so I can draw the line. Done. 2, 3 and 3, 4 I am having the point. Yes, 2, 3 and 3, 4. Now, you can easily understand the point here. Yes. The point is, it is intersecting at this point only. So this point becomes I24. So I24 and I23 are same point actually. So now what will be the distance? 24 to 12, 24 to 12, 2 centimeter. 24 to 14 will be what? Total is 10. Subtract 2. What is the remaining value? 8. So omega 4 I have to calculate, which is what is the omega 2 value they have given? 5. So omega 2 value is 5 multiplied by 2, 4 and 1, 2. 2, 4 and 1, 2. That is 2. 2, 4 and 1, 4. 10 minus 2, 8. Omega 4. So what is the answer of omega 4? What will be the answer? You can do the calculation basically. Tell me, what will be the answer? Final answer. So angular velocity ratio theorem is the easiest way to solve any velocity related problem from simple mechanism chapter. Velocity diagrams or relative velocity method is also there, but for that first you have to figure out what are the velocity vectors. After that you need to figure out how to draw velocity diagram. Then you will be able to get the answer from velocity diagram. This is also the method, I center method, in which angular velocity ratio theorem is there. But if you are comfortable in locating I center, this method will take less time compared to that velocity diagram method. Clear everyone? Is it clear? So 2 by 8, so will be what? 5 by 4. 5 by 4 will be there. So 5 by 4 is basically our answer. And if you simplify it, it becomes 1.25. So that is what we are having as the final answer here for this problem. Clear? Final answer. Done. So we have solved almost all the problems. Some of the problems are left actually, and that are basically easy problems you can solve. These are the major problems in which student has suffered some of the issues. So that I have solved here. Okay. 1.25, not 1.5. It will be 1.25. Okay. 5 divided by 4. It will be 1.25. Done everyone? Okay. So today, as we have solved like 2022, okay, GATE previous year problems, in the next session we will be solving 21 GATE 2021 problems we will be solving. So like this way, already some of other subjects are also going parallelly, like thermodynamics, right? So you should prepare first of all PYQ. Once you have done the PYQ, you will gain some confidence. Then you can easily switch to some other practice problems as well. Okay, and please try to give full length mock test, which is very important. See, you are doing preparation, but you are not evaluating how much you are doing, then there is no point. So take mock test as a feedback. It is just a feedback how much preparation you are doing and how much more you have to do. That will be clear when you will give the full length mock test. Yes, production, yes, definitely will take production also after some time. Okay, so right now this theory machine, it is happening, and thermodynamics is happening. After some time, maybe production will also happen. No issue about that. Okay, so thank you so much for attending the session. So please share this session to your friend also, and make sure in the next session you should come live, and other sessions which are going parallelly, you should attend all those lectures. And in the month of November and December, we'll be having your rank booster sessions also, like GATE booster session, that will be taking, in which expected questions will be discussing in the live sessions. Okay, thank you so much, and keep doing your great effort for your GATE preparation. Okay, thank you so much guys.